We have considered a current can conduct. The direction of magnetic field is along z-axis. The magnetic field we have considered along the z-axis, and the wire is placed along the y-axis. It means the angle between magnetic field and the wire is 90 degree, and we have considered the length of the wire which is in the magnetic field L, and area of cross section of the wire is A, and some other factors we will consider here, that is uh, N is the free electron density, and Vd is the drift velocity of electrons. I is the current flowing through wire. E is the charge on an electron, and rest of the things I have told you. A is the area of cross section of the wire. Current is flowing from, let us say this is P and Q, P to Q, then electrons must drift from Q to P as shown. If the current is flowing from P to Q, that is, this is the direction of flow of the current, and it means electron must be moving in opposite direction, that is from Q to P. And here we have considered one electron at the origin of coordinate system, that is O, negative sign, and it is drifting with velocity Vd from we can say that y to y dash, that is from Q to P. Now as this electron is moving in a magnetic field, and here the magnetic field, as I've told you, it is along z axis, then according to Lorentz force, the force acting on one electron will be, that is, force on one electron, it will be Q. Q means minus E, V cross B. So therefore force will be, actually formula is Lorentz force is given by QQ V cross B. Now here Q is the charge on the electron, V is the Vd, that is drift velocity, rest of the same things, and we have changed the sign of this one. Fe, that is the force on the one electron. So this is the force acting on the one electron. Now as we have considered here, that is n is the free electron density, that is number of electrons per unit volume. So therefore if n is the free electron density, then total number of electrons present in the given volume of the wire, number of total electrons present, it will be equal to number of electrons per unit volume into volume of the wire, and number of electrons per unit volume n, and what is the volume of the wire? Length into area of cross section. So therefore total number of electrons becomes NLA. Now if this is the force on the one electron, then what will be the total force on the all electrons, and that will be the force on the wire. Therefore net force acting on the wire will be equal to force acting on all moving electrons, and it will be equal to number of electrons multiplied by force on one electron, and therefore number of electrons are at NLA, and force on one electron is minus, let us say it is the F. It will be equal to minus E into V cross B, and NLA minus E VD cross B. Now I can write this expression as minus N E A L V D cross. Now I can write it down in this one, L minus N E A V D cross B. Now as I is equal to N E A V D, therefore I into L is equal to N E A V D L. Now because of electron there will be a negative charge, and then we can represent in a vector form. So therefore minus NeAVDL actually is equal to I into L. So therefore this whole can be replaced by IL. So therefore F becomes IL